So as I understand, it's really kind of overwhelming when you take a look at everything that you have to remember for pre-calc. What I wanted to show you, and I did show you in Unit 1, was that there was a hexagon that can be used for reciprocal and Pythagorean identities, and it's just a way to remember. So I drew a very archaic version of a hexagon. So here's a really nice hexagon, and I drew it like you would a star, and then I made my triangles, and I said you start with sine squared here first, and then you go alphabetically around to each vertex of the respective triangles. So this would be cosine squared of x, this would be cotangent squared of x, cosecant squared of x, secant, and tangent. And this goes, except for the sine, in alphabetical order. So you notice these right here, these lines the white triangles basically do not exist. The ones that I've highlighted are the ones that exist, and we have a 1 in the middle. So I took this pink triangle out, and I brought it down here. So we have sine squared of x plus the cosine squared of x is equal to 1. So this is our first Pythagorean identity, and it's the main one. So here's what we have. Then we can take this and manipulate it any way we want, meaning if I want to solve for sine squared, I subtract cosine squared. So these are equal, and they all go back to the original Pythagorean. Then, going back to the original, to solve for cosine squared, it's 1 minus the sine squared. Instead of memorizing, I have a way to have every single Pythagorean identity in front of me, which is essentially a total of 9. So I go back up to my hexagon. I ignore these triangles, and I take this orange one out. So that leaves me with 1 plus the cotangent squared of x over the cosecant squared of x. Here is my triangle. Across the top you add, and you go down this way, and it's what this sum is equal to. Okay, so you have 1 plus a cotangent squared is equal to the cosecant squared. If I wanted to solve for 1, I subtract the cotangent squared. So you have cosecant squared of x minus cotangent squared of x. That's another variation of the theorem. Go back to the original. If I wanted to solve for the cotangent squared, you subtract 1, so that leaves me with the cosecant squared of x minus 1. These are all variations. So now I have a total of 6. I go back up to my hexagon, and I highlighted this in green. So I'm pulling this triangle out, and I'm putting it right here. This is the tangent squared of x plus 1 is equal to secant squared of x. So you have tangent squared plus 1 is equal to the secant squared. If I want to solve for tangent squared, I subtract 1. If I go back here and I want to solve for 1, I go back to the original, I subtract tangent squared. You have 9 of your identities right here. Now, one quick thing that you can look at too is the reciprocal identities are obtained by looking at the diagonals. So let's go up here and look really quick. The sine squared, its reciprocal is cosecant squared. Cosine squared, its reciprocal is secant squared. Tangent squared, its reciprocal is cotangent squared. Diagonals.